Yeah, ask others also to join. I need to finish this topic today, introduction part, so that we can move further.
Hello, doctor.
Hello, hello.
Hello, doctor. I can't hear your voice.
Yeah. Hello. Are you able to? Am I audible?
It's not clear your voice.
Right now, I am not speaking anything. Okay. Just I am waiting for people to join. Okay, so we are discussing about the scientific method. Are you able to see the PowerPoint slides?
Yes, doctor.
Okay. So we are
Okay, thank
discussing
you.
the scientific method, how we are going to perform the research. Okay. In- The first step in the our research should be to define the question. What question you want to answer? What is the problem? How, what to solve? And for that purpose, you are going to, let's say, you all people are going to do your master thesis, right? And for that, you have to find out a research question that has to be solved as your master thesis. So first you have to design that question. Question means a kind of problem you want to solve through research. In terms of the research, it is assumed that there should not be prior solution of that particular problem. You are going to give the solution for the first time, or if there is a solution that may be different in nature, your solution should be different one, more superior. If some solution is available earlier, somehow is given, and if you are going to modify that one and come with a better solution, that can be a research also. right? So how we are going to perform? First, you have to define your problem or your question. Then you are going to gather information and resources. That means you are going to observe the particular phenomena. You are going to perform the experiment or whatever that may be. And gathering information means collecting the data. It requires a lot of data, information, right? So, yes, Umar Mohammed, you want to say something? Okay. So, we can say that we have to get the full understanding. For that understanding, we want to get the data about that particular phenomena to which a particular problem is related. And then we are going to make some hypothesis, some predictions. Okay, there may be result like this one. Like if you are going to assume that making a hypothesis that if I'm going to increase the speed, the surface finish will be good in a particular turning operation. Let's say that may be hypothesis. Then you are going to perform the experiment, collect data. Here, gather information means you observe the phenomena, you collected the information. What are the different parameters involved? Maybe speed, tool material, workpiece material. These are the different parameters information there. What kind of tool, what kind of that may be. These are the resources. Then you're going to design your experiment and perform that one. There are so many efficient way to design the experiment. We'll discuss about that one. And let's say from that experiment you collected the data. You have put the speed at this level, feed at this level, depth of cut at this level, and your surface finish is this one, material removal rate is this one, and so on. So here something should be input and some parameters should be output, like depth of cut, speed, feed rate, etc. etc. These are the inputs. Material removal rate, right? Material removal rate, surface finish, time required, or cost associated, whatever that means. These are known as the output parameters. And there may be some relationship we have assumed at the step 3. Now we have to analyze that data. Once you collected the data, input data and the output, what you have, then you are going to perform the analysis. And you are going to interpret that data and draw conclusion. If conclusion is going to validate your hypothesis, then it's okay. You can go and publish your result. Otherwise, you are going to change your hypothesis again, perform your experiment and analyze data, and this cycle will go on till the hypothesis you have assumed or you have written that is going to confirmed by the interpretation of the data, right? Once this is done, then you have to only publish the result, publish in form of some research paper, journal paper, or in form of your thesis. Your research finally going to end here. Now here that is the publication of result, research. And sometimes to validate that one, some other people is going to set the same environment, same kind of experiment, and they can retest. Okay. So iterative cycle in this step by methodology goes from the 3 to 6 to 3. This is the iteration. Okay. So this is the scientific method. Simplified form, we can say that generate hypothesis, design experiment, for our case, engineering case. Perform experiment. From experiment, you are going to get the sun data collect the data. When you are going to perform the experiment, there should be some input data, input parameters for which you have the data, some output parameters. Already I talked about that one. Let's say if you are going to do some sort of the machining operation for any machine, there should be cutting speed, there should be depth of cut, there should be feed rate, there should be coolant, type of coolant, right? So these can be the input parameters, and they may have the different levels. Speed, maybe you have on a particular machine, let's say you have the 10 speeds, 9 speeds, 12 speeds, whatever that may be. Okay. So when you are going to change the one parameter, one speed, that experiment will become a new experiment, keeping all other factors same. So let's say for the one parameter, you have the 3 levels, and let's say there is 3 levels, 3 to power 3, there should be at least 9 experiments, changing all this. And generally, when you're talking about the three levels and 3 parameters, these are very simple. That doesn't happen in the engineering. There are a lot of the parameters, a lot of the levels. And in that case, you can have the thousands of the experiment to be performed. That was very cumbersome, very difficult task. So here comes the design of experiment that resolves that problem by minimizing the number of experiments to a certain amount without compromising with the final result. Result will be more or less same. So we will here use some sort of the design of experiment method. Here, design the experiment, then perform as per that design. From that we collect the data. Data we analyze and accept or reject hypothesis. What hypothesis we have made here? Some relationship we assumed. Whether that is true or not, if not, again change this hypothesis. The same thing. Here, whatever we have discussed, the same thing is represented in the graphical form here. To make it more clear, what is the hypothesis is, let's say, when you are going to predict or say something about what should be the possible answer to a problem or question. Possible answer, you don't know. Exactly, you don't know. Okay. So you are going to make a guess. What kind of guess? Based upon the some intuition, some knowledge, some expertise you have in your field. So this kind of guess is known as the educated guess. Not a random guess, okay? There is some education behind it. There is some background you have in that area. So most of the time, hypothesis is written like, if I do this, then this will happen. I already told you. Like, for example, let's say, if for agriculture purpose, if soil temperature rises, if soil temperatures rise, then this is some kind of if and then statement, okay? If soil temperatures rise, then plant growth will increase. And this is just a guess. You can't say this is a fact. To verify this one, you have to observe how the plant is growing when you are going to provide the different soil temperatures. And is they really increasing the temperature is going to increase the plant growth? That both things, soil temperature and plant growth, should be measurable. Then only you can apply that. Okay. And in our thesis or research paper, we don't write hypothesis like this one. If this is for the understanding purpose, if and then statement. Okay. So how we write? If you see the objective in the any thesis, they write to study the effect of the soil temperature on the plant growth. To study, to investigate, right? To design. This kind of statement informs the objective you write. Okay, but this is saying the same thing. What if soil temperature rises? This is a kind of the hypothesis. Plant growth will increase. If hypothesis is accepted, that means soil temperatures rise, plant growth increase. If hypothesis is rejected, then there should be no plant growth at all, or there should be negative. Both can be possible. Right? So I understand you. Hope that you understand what hypothesis is. What is the importance of knowing how research is done? No doubt, for career in the research field, someone wants to make, he should be very well aware of how to do the research. If you know how to do the research, that will put a confidence in you, reasonable confidence. You can analyze the research done by others. You can trace their results. Also, your mind tends to be objectively, not the subjective one. You always find out the facts and figures. You will take the better decision based upon the facts. You know, na? Decision taken in terms of the emotion or anxiety or anything is not good. It is said that whenever you are angry, don't take any decision. Because that decision is taken when you are full of the emotions, when you are angry upon anything. Your thinking process is interfered by your emotions, and whatever decision you are going to take, that is not based upon the facts and figures. And most of the time, that kind of decision are proven to be wrong, detrimental, not beneficial to us. So it is said that whenever you are very angry, very sad, or very happy, don't try to take any decision, whether that is the personal life or professional or whatever that may be. Right? Because at that time you are not considering the facts and figures. Objectively, you are not looking at the life or that particular phenomenon. At that time you are biased. You are under the effect of your emotions. That emotion may be the happiness, that emotion may be the enviness or whatever that may be, sadness. So whenever you're going to take any decision, you have to get rid of the emotions. And objectively, objectively means that is the opposite of the subjective. Subjective means based upon the opinions, based upon the intuition. Objectively means based upon the facts, figures, data, truth available in front of you. Yeah, Dexter, you want to say something?
No.
Okay. So this research methodology provides a tool to look at the things in life also. When you become habitual, you look for the objectivity. You can't be biased. You will be more rational person. You will believe in the logic more than your intuition or opinion or whatever that may be. In this scientific age, all of us are in many ways consumer of the research results. Of course, we are using so many things in our practical life, whether that is mobile or anything. Desta, please mute your microphone if you're not saying anything. We are able to judge the education method by which they have been obtained. So we can judge the adequacy of method by which they have been obtained. Okay? We are now a part. Sometimes we act like a consumer, sometimes we are researchers, like that. So we can summarize the research process like this for our purpose in the field of the manufacturing technology or manufacturing management. First step you are going to do to perform any research. Please keep in mind we are going to have some activity upon this one. You are supposed to, when you are going to complete this course, you are supposed to come with a very good research proposal that should be submitted to the department for your research starting in the next semester. And if prior you are doing some activity seriously, you don't have to do it again and again, right? This will work as your research proposal, and you can further expand your research in the form of the master thesis. So my objective is that each and every student of this course should be able to come with some research topics of their choice in the area they want to do the research, and also able to define the problem, and at the end, of course, they should be able to come with the two things. One is the research proposal, and second thing is the completion of their literature review, basic literature review. Okay, or literature survey. Okay, so first you are going to formulating the research problem. Once problem is known to you, you want to collect the data or understand the problem in a better way. For that, you are going to do the literature survey. What are the different people, how they tackle this kind of question, related questions. What are the different methods they have used? Can I adopt some method from them, or can I design my own method like this one? You see how much work have been done in a particular area, particular field, and where people have not touched, what is the research gaps? And if you find the research gap, that should be a very good research. If you are going to fill that research gap, you can do the wonder. If you find a research gap, and for finding the research gap, you have to be very careful, and you have to do comprehensive literature review. You have to collect all concerned literature. There are some tools we'll discuss during the literature survey or literature review class, when we are going to discuss that how to conduct the literature review. Okay, so there are some tools you can apply. Then you are going to establish some relationship, hypothesis. Then you are going to prepare the research design, how to conduct the experiment, how to conduct the interview, how to distribute the questionnaire, what should be the part of any kind of. This is the research design. Determine the sample design. You are going to do a pilot study, initial study to validate your experiment. Then that pilot study is for validation of the initial design. When that design is validated, you are going to collect the data, execution of project, analysis of data, then testing hypothesis. That means you are validating the statement you thought of. If this is the case, this will happen. That is accepted or rejected. If that is accepted, then you are going to generalize that interpretation, interpret that result, and finally preparation of report or the presentation of the results. This research process we are going to follow. This is based upon this scientific method. And as an engineer, we are most, in that case, we are going to follow this scientific method for our research. Okay. So this is in terms of the flow diagram. Define the research problem, review concept and theory. This is the literature review. Formulate hypothesis, some research questions, whatever that may be, you're going to formulate here. Then design research, sample design, whatever that may be, design experiment. Performing that one is from the performance you are going to collect the data, analyze the data, and finally you have the interpretation and results, and that can be written in form of some reports, thesis, research papers, whatever that may be. Here you can say there is some feed forward and feed backward analysis of data. Here you are testing the hypothesis, a backward coming here, right? Here you can say feed forward, here feed backward. Sometimes result comes in such a way that we require to define the problem in a new way, a new problem for the further research. You are supposed to give some direction based upon your research. What should be the future research direction? In which direction particular area will go? What research should be done? What is left? What is unknown? One person cannot solve all the questions, all the problem in a particular area, right? So now some general talk. Three pillars of science. One is the knowledge, second is the method, and third is the attitude. Knowledge is the basic fact and data, theories, whatever that is. Method, you are going to apply to evaluate the efficacy or the effectiveness of the scientific theories by comparing prediction like this one, observation, experiment, whatever you want to do. That should be known as the method. When I'm going to compare, evaluate or something. Most important is the attitude or belief that anything, any theory, anything is questionable. You can question anything. This is not a matter of the faith or the religious or something like that. In science, everything is always available for the questioning. And if you're not going to question, you can't go ahead, you can't develop new things. When people question the Newton's law of the gravitation, they got the theory of the relativity. If they got satisfied with the Newton's law of gravitation, Einstein won't be able to develop the new theory. Right? So, skeptical inquiry with the doubt is very necessary. You have to doubt each and everything. And then you can confirm, okay, this is happening or not. Okay. What should be the good research? Good scientific research. That should have a purpose. Purpose means some aim, some goal has to be achieved. So that started with a definite aim and purpose. Right? Rigor means having very good theoretical base. That's why I say always to our students, do the literature review very comprehensive. That empowers you, that gives a new knowledge. Reading a lot of literature will provide you understand the problem in a better way. That will give a lot of knowledge to you. And on the basis of literature review, you can modify the problem also. Okay? Now, third one is the testability. That should be testable. This is not an opinion. This is a research. This is applicable to all persons. This is not a personal thing. And also, this can be replicated. Research should be replicated means that can be, when you are going to set the same parameters, the result should be same. Replication means making the copy. So research results supported when research is repeated in other similar circumstances. Replication should be possible. Only that kind of research will be known as the good scientific research. Precision and confidence, there should be. Closeness to finding the reality. Sometimes when you are going to do the research, we assume something. Whenever you are going to take the assumptions, and that is also necessary, because sometimes you are not able to replicate or reproduce the real situation in the theoretical one or simulation. So you go for the some assumptions, but your findings or results should be more close to the reality, solve the real problems. And also the probability of the estimation, results, or whatever you find out. There should be high probability of that should be correct. Sometimes it happens that result is totally incorrect. You know, in the research, if you are going to fail also, that is we consider as a research, no problem. If you are coming with the different results, opposite results, that is also a result. That's why we say that hypothesis. Either you are going to accept the hypothesis or you are going to reject one. From that, both acceptance or rejection of the hypothesis, we are going to get some information. Either there is some relationship between the two variables, three variables, or there is no relationship. That has to be confirmed. So anyway, both ways, you are going to get some information, some new things. Objectivity, always I say that don't believe on your subjectiveness, be objective, believe on the facts, figures, data. Generability, your application of the results, findings can be applicable to other settings also, not in the only one setting, not at the only one place. And finally, the parsimony, that is simple in explaining the phenomena. Simplicity should be there. And that can be extended to solve the other kind of problems also in the different areas, different field. Okay. So these are some of the characteristics of the good research. Here, what is the basic input for the scientific research? That requires intelligence, imagination, and creativity. And don't think that this is a rare thing. If you try, each person has that kind of the mindset, bend of mind. We have the intelligence, we can imagine, we can be creative if we try to. And this is the ongoing cycle of the constantly developing more useful, accurate, and comprehensive models. Right? This is research is not the one-time thing. Always you have to improve or improve and improve. Today, whatever result you get, that may not be so correct. Someone come in the future, they will improve that one. Right? Like if you see this, I mean, geocentric model, that they have thought that Earth is at the center of the solar system or a universe. That time, that model was accepted because there was no more information available. But later on, Copernicus comes and he said that heliocentric, that sun is at the center of this solar system. and including Earth and the other planets are rotating in a particular fixed orbit around the sun. Today we believe this one. So you can't say this is Taguchi method was not a research. For that time, whatever information available, whatever he came with that result. So it is consistent, developing day by day. Okay. Same thing. I already told Newton's law of motion came in the 1688. Breaks down when velocity approaches that of light, and from that we got the special theory of relativity. So that is the improvement upon the already built theory. Newton's law of the gravitation, 1666, breaks down when gravitation becomes very strong. This is the general theory of the relativity. I already told this to you. Okay. So don't think that research is a full and final thing. That is an ongoing cycle. Today, whatever result you come with, that is validated, all people accepted. Maybe tomorrow someone will come and claim that, okay, no, there is some improvement in that one, that is not a correct one. In the certain circumstances or like that. I hope you understand this one. So don't worry about the results. Okay. And some of the, if you want to believe, some of the topics, like you see, what is the difference between the truth and belief? If you see the pictures of the flying horse, they are generally replicated like forward legs in the forward position, backward legs in the backward position. But if you see the real picture of the flying horse, when all the legs are in the air, they are like this one. So this is the truth, and generally we believe looking on the picture of the. So we have to be so much conscious to differentiate between the truth and wrong beliefs. Okay, other things. Some history of the development of scientific research methods. Plato and Aristotle, earlier philosophers, they are known as the founder of the philosophy, laid down the founding stone for the development of scientific research methods, right? And for a detailed knowledge, you can refer to this link of the Wikipedia, timeline of the history of the scientific methods, right? If you want to learn more, you can refer to this link.
Okay. Thank you, sir. And upload the video or today class.
Okay, I upload, no problem. And also remember this: when someone is going to discourage you or someone is going to say something, some great scientists made some prediction and they were wrong. Like computer in future may weight no more than 1.5 tons. If I think there is no world market for maybe 5 computers. Chairman of IBM in 1943. Now see, each and every people have the PC, laptop, etc. Airplanes are more interesting to us, but no military use. Someone said, merchant professor of strategy. That is proven wrong. I like that one. Heavier than air flying machine are not possible. Royal Society, London, President. Now we travel in the planes. Heavier than air flying machines. 1895. So some errors experts do when making some comments, but we have to question everything. We don't want to believe on the saying.